Intro to functions. What is a function? Alright, so what exactly is a function? Let's talk about functions. Before we really get into the exact notation of functions, let's just take it back a couple of years, and let's go back to like second or third grade. In second or third grade, you're probably used to seeing these machines, right? In these machines, you're plugging some number in up here, and then boom, out pops some number. And then your job is to guess, well, what's happening inside of the machine? So let's say I plug in the number 4. Plug in 4, out pops 7. Okay, don't really know what's happening in the machine yet. We might have some sort of idea. So we plug in some other number. We plug in 5, and out comes 8. Okay, now we definitely have a better idea of, well, what's going on here. And in second grade, they probably had you fill inside the circle. What do you think just happened? Well, I think we're probably adding 3, right? 4 plus 3 gives me 7. This 5 plus 3 gives me 8. Okay, so the question is, what's happening on the inside? Probably plus 3. If I plug in some number, I add 3 to it, that's what's going to come out. Okay? So then we jump forward a couple of years, and let's say now we have some sort of y equals equation. Well, this up here, these are our x values, right? So if I plug in, let's say I plug in the number x, right? X is our variable, it represents some number. So if I plug in x goes into this machine, and what's going to pop out? Well, x plus 3 is what comes popping out. And again, when we're trying to graph, well, if these are my x values up here, well, what comes out is my y values. These are all my y values. So you were probably taught, well, this gives us the relationship y equals x plus 3, where x is my input, right? This is what I'm putting into the machine, and then y is my output. This is what I'm getting out. So y equals x plus 3. Well, this is where we're going to introduce function notation a little bit. We're going to talk about, well, we want to call y equals some function of x. That's what this means. This f of x, some function that's operating on x. All of our y values will be, well, I plug in that number, the function operates, and out comes my y value. So we can say f of x is equal to x plus 3. So let's talk a little bit more about the terminology that goes on with functions. Anything that we're plugging into the function, anything our input, our x values for the function, is known as the domain of the function. Okay, so whatever we're plugging into our function, that's the domain. Our x values, our potential x values, are the domain. Anything that's coming out, so all of our output, that's known as the range. Okay, the range of my function. All of those y values, the output of my function is the range. All right, so let's try and look at this definition of a function in just a different way. Here, let's use mapping. Okay, so if you want to take a look at this, over on the left side, we have our domain. Okay, everything in this circle, everything in this oval here is my domain. Goes into the domain, goes through this function f of x, which I'm still saying that f of x is x plus 3. Okay, and it's going to come out as the range, the output. Everything in this circle is anything I could get out of this function. Okay, so let's start just by saying, well, let's say we have the number 3. Okay, goes through the function. It's going to come out as 6, right? 3 plus 3 gives me 6. Okay, if I plug in 4, that maps over to 7. 5 here maps over to 8. Negative 22. I don't know, the most random number I could think of. It's going to map over. I add 3 to it, negative 19. Okay, so this is just another way of viewing it. You take a value in your domain, put it into the function. So for the first one, I take 3, plug it in, add 3, and you get out 6. So 6 is that value in your... So now let's look at what exactly makes something a function versus something else that's not a function. So in a function, for every input, there is exactly one, and that is the key word here, one output. Okay, so say if we go back to that machine and I plug in the number 3 and I get out 6. If I plug in the number 3 again, I better get out 6 because that machine needs to be acting on the 3 the same way every time. If I plugged in 3 and I got out 6, then I plugged in 3 and I got out 7, well then what is the function? There is no function. For any number that I input, you can only get out one possible output. That's the definition of a function. All right, let's take a look at another function. With this function, we have f of x equals x squared. So what we're saying is, if we go back to that machine, any number that I plug in, I'm just going to multiply it by itself, right? That's what squaring is. And that's going to give me my output. So here, let's say I plug in the value 3. 3 goes in. 3 squared is 9. If I plug in the number 4, plug that in, and I'm going to get out 16. What if I plug in the number negative 3? If I plug in the number negative 3, that's also going to give me 9. Is this a function? Yes, it is a function, because for any number that I plug in, I'm still only getting out one y value. Okay, it's okay if two x values go to the same y value. It is not okay if one x value goes to two y values. So yes, this is a function. This is a function. There we go. All right, so the question now is, well, is this a function? Well, let's take a look. x1 maps directly across to y1. x2 also to y1. Is that all right? Yeah, that's fine. x3 maps to y2. x4 maps to y3. So is this a function? Yes. Yes, this is definitely a function, right? Each x value maps to just one y value. It's okay that x1 and x2 both map to y1. That is fine. If you think back to that example with x squared, that's okay. All right, let's take a look at another example. Here we have some x1 is mapping directly across to y1, x2 mapping to y2, x3 maps to y3, and it also maps to y4. Is that okay? No, of course not. No. Of course not. Okay, that's not a function because that means I'm plugging in one x value and somehow I'm getting out two different y values. That does not make sense. All right, so let's take a second and let's go back to something that you're probably pretty familiar with, and that's just graphs on a coordinate plane. And we want to figure out, just looking at the graph, is this a function or is it not a function? So let's start. I'm just going to draw some random curve here. Okay, we'll go like this, loops back around. All right, so that's the graph. Now, the question is this a function? So, is this a function? Well, how can we figure this out? if we just think back to, well, any point on this graph we can call, right? This is some point x comma y, right? Has some x value and some y value. If I want this to be a function, well, that means for every x value, I can only have one y value. Well, let's say I pick this point here, what's going on? Let's say I pick this point here and this point here. Well, both of these points probably have about the same x value, right? I don't know what that is. We'll just call it some x value 12. I don't know. Okay? But clearly they have different y values, right? Same x value. They're right along this line here, but completely different y values. So is this a function? No. Again, this is not a function. And how can I figure out if something is a function? Well, if I draw a vertical line through the graph, it can only cross at one point. So it's only crossing the graph at one point. Over here, this is all good, right? I draw a vertical line, it only crosses right there. But here, I'm crossing at 1, 2, 3 places. So that means for one x value that I'm plugging in, I'm getting out 3 different y values. Clearly not a function, okay? And this is using, well, what did I draw here? I drew a vertical line. So this is using the vertical line test. Okay, I use the vertical line test to check and see if something is a function or not.